Hi students, welcome back. Let's continue with the subject compiler designs. In this video, I want to explain about LR parsers. I already explained that there are different types of parsers. The different types of parser, one is the top-down parser and the bottom-up parser. So in the top-down parser, we had seen what is a backtracking and predictive parser. That is nothing but LL parser. Now let's see the bottom-up parser. So bottom-up parser is also called as a shift reduce parser. So we explained, I already explained about the shift reduce parser. One of the examples of the bottom-up parser is the operator precedent parser and LR parser. So we completed the shift reduce parser and the operator precedence parser. Now let's see what is LR parser. So far whatever the videos I explained about the parser is backtracking, LL parser, that is a predictive parser, shift reduce parser, operator parser. So these comes under the bottom up and these two are the top down parser. Now let's see the another type of bottom up parser. This is LR parser. Okay. So now let's see what is this LR parser. LR parser is again of there are different types are available. Okay, so mainly three widely used algorithms available for the LR parser for constructing. So those are SLR, LALR, CLR. Okay, LR parser is divided into LR0, SLR, LALR, CLR. Okay, SLR means simple LR. LALR is look ahead LR and CLR is a canonical LR. So from going this side, LR0 is having the least powerful and whereas CLR is the most powerful. Okay, so when compared to this from left to right, the LR0 is having the least powerful and CLR is most powerful. So what is this LR parser? So in this video, I want to explain what exactly the LR parser was. Okay, so LR parser in the coming videos, we will see with an examples. So LR parser. LR parser is a non-recursive shift reduce bottom up parser. We call it as a non-recursive shift reduce bottom up parser. Okay, it is also known as LR of K. It is also known as LR of K. Okay, it is also known as LR of K, where L is the left to right scanning input stream. Let me write this. L, you call it as a left to right scanning input stream. Left to right scanning input stream. Then what about the R? R stands for the construction of rightmost derivation, which is in reverse. Construction of rightmost derivation in reverse. So just remember these terms. L is left to right scanning input stream and whereas R is the construction of rightmost derivation in reverse. And what about the K? K denotes the look ahead symbol. Look ahead symbol to make decision. So this K is used to make decision. So this is the LR of K. L stands for left to right scanning input stream. R is a construction of rightmost derivation in reverse. And K is a look ahead symbol which is used to make decisions. Okay. And I said there are three widely used algorithms available for constructing an LR parser. That is a SLR, LALR and CLR. Okay. So the canonical LR we already used, we will use in these examples while we are discussing. So the main three available algorithms for constructing LR parser is LR0, CLR1, LALR1. Okay. Now let's see what are these terms are. SLR1. What is SLR1? So SLR1 is nothing but the simple LR parser. S stands for simple. Simple LR parser. And it is works on smallest class of grammar. Let me write the points so that it is useful for you. Works on smallest class of grammar. And SLR has few number of states, hence very small table. So it's having only few number of states. So it contains very small table when compared to the other LR0. And it is a simple and fast construction. SLR is simple and fast construction. So these are the features of the simple LR parser. Now let's see the next one, LR1. Let's take LR1. That is nothing but LR parser. So it works on a complete set of LR1 grammar. Works on complete set of LR1 grammar. And it generates large table and large number of states will be there. So here there are few number of states and LR1 is having the large number of states. Whenever the states are increasing, obviously the table is also becomes big. And if the table is more, means which generates a large table means slow construction. Few tables, few state means only the simple and fast construction, whereas LR is having the slow construction. Now coming to the next available algorithm, that is LALR. LALR is nothing but look ahead LR parser. So it works on intermediate size of the grammar. Here LR works on the complete set of LR grammar, whereas LALR works on intermediate size of grammar. And number of states are same as SLR. So then it is simple and fast to construct. Number of states are same as SLR1. So just remember these points and the features of SLR, LR and LAR. Let's see the structure of LR parser. Later we will see the examples, how the LR is going to be constructed. Structure of LR parser. So LR parser consisting of a stack which holds the data, and stack starts with the empty symbol, and it consisting of LR parser and input buffer LR parsing table. Output. This is structure of LR parser. Actually, so whatever the parsers you are taking, that is LR1 and SLR1, LR0 or LR1, whatever it may be, and SLR1, LA, LR1. So for all these available algorithms, this structure is the same. So they use the same stack, the same input buffer and LR parser, everything will be the same, but only difference is a parsing table. Each algorithm is having their own type of parsing table. Okay, so whenever you are solving the problems of LR parsers, okay, the stack implementation, input buffer and construction of LR parser, everything is same for all the algorithms, but the only difference in this here is the LR parsing table. Okay, so each having their own technique, because in the parsing table itself, whatever the features you have seen that here in the to construct the parsing table, you need the states. So SLR is having only few states, and the construction of the table is also construct only few states. Okay, means the construction is very less. A few number of states, hence very small table is required. SLR requires very small table, and whereas LR requires large number of states, means large table is required. And LALR is having the same states whatever the SLR is having. Okay, so everything whatever the grammar that is present that is used in LR, SLR, LALR, everything is the same. The only difference here is the parsing tables whatever they are using. So LR parsing algorithm requires a stack, input buffer, and LR parsing table from all these parse table. So the stack and input buffer LR parser algorithm is same, but only difference is parsing table. So to construct LR of 0 and SLR1 tables, we use canonical collection of LR0 items. So these points you just remember that. To construct LR of 0 and SLR of 1. If you want to construct LR of 0 and SLR1 with the first two items, okay, whatever here it is present, the first two items, LR of 0 and SLR1 tables, we use canonical collection of LR0 items. So to construct a table, it requires the canonical collection of LR0 items. So just remember this word. So it will be helpful to you while you're constructing the tables. So to construct LR of 0 and SLR1 tables, we use canonical collection of LR0 items. So what are these canonical collection of LR0 items? You will see in the examples. Okay. And next, to construct LALR of 1 and CLR of 1 tables, the remaining two, we use canonical collection of LR1 items. So for constructing LALR and CLR, we use a canonical collection of LR1 items. Okay, so this is just an introduction part of the LR parser, how the LR parser having the different algorithms, LR0, SLR, LALR and CLR. Okay, and this is the structure of LR parser. So in the next videos, we will see how to construct LR0 parsing tables, SLR and LALR. Thank you.